This is a video about the rational zeros theorem, and I've kind of written here in text in plain speak what the rational zeros theorem says. It basically says if there's a zero of this polynomial over here and it's a rational number, in other words an integer or a fraction, you can find it by taking all the factors of that last number, in this case which is 20, and dividing it by all the factors of the coefficient on the first term, in this case which is a 10. If it's complex numbers, I can't help. That's what the rational zeros theorem kind of says. The textbook's going to say it a little bit more efficient way, maybe more high-speak way, but stating it as clearly as I can. So what we do is we call this P over Q. We call a fraction P over Q, and P is all the factors of this number 20. So your P, you're looking here for P, and over here, this is what we call Q. So P is going to be the factors of 20. So we got to think of all the numbers that multiply to give 20. So the factors of 20 are 1, 2, 4, 5, 10, and 20. Of course, just think what number goes into 20. 1 goes into it, 2 goes into it, 4 goes into it, and then you get the other factor pairs that go with that. And then Q is the factors of 10. So the factors of 10 are 1, 2, 5, and 10. And so what we're going to do is we're going to create fractions out of P over Q. All right, so you have to think of all the possible P's over all the possible Q's. All right, so let's start with if P is 1, so we could have 1 over 1, so this first P over all these Q's, 1 over 1, 1 over 2, 1 over 5, and 1 over 10. So all those things right there are possible factors of this polynomial. And the rational zeros theorem also clarifies that we don't know if they're positive or negative, so we have to put a plus or minus in front of this. And we say plus or minus 1/2. It could be a negative 1/2, it could be a negative 1/5, it could be a negative 1/10, and so on. All right, so now we go to the next number in P, which is 2. So put 2 over 1, 2 over 2, and let's stop right there at 2 over 2. When I write 2 over 2, I've repeated myself, right? Because that's 1. 2 divided by 2 is 1. And so we already have 1 on the list. So what you're going to find here is you're going to repeat some numbers. So 1 over 1 and 2 over 2 are the same thing. But I'm going to continue out and write out this whole list of numbers, and I'll cancel out all the ones that are duplicates. So you see I have my list. So all the first ones hold, but then we have, like we said, 2 over 2 is the same as 1 over 1. That cancels. 2 over 10 is 1/5. We already had that one. 4 over 2 is 2. 4 over 10 is 2/5. And so go through that whole list. I'm not going to go through them all, but you can see that, especially as you get to the later ones, most of them cancel. Even 20 over 10 is just 2, and we had that way back here at the beginning. So when you want to make your list of all the possible factors, notice how my MATLAB does it. It starts out with the integers first, and then it does the fractions. So we have 1, 2, 4, 5, 10, and 20. And I didn't write plus or minus here, but they all should have plus or minus on them. And then for fractions, we have 1/2, 1/5, 1/10, and then we have 2/5, and then we have 4/5, and we have 5/2. And then that's all of it. So therefore, answer choice B right here is the correct answer for part A. All right, so if you thought that was hard enough, I hate to tell you it's going to get a little bit harder, because now what we have to do is a trial and error of all of these possible numbers to find one that works. And so the way we find one that, quote, works is that we start by using the very first one here, which is plus or minus 1. Let's start out with positive 1, and let's see if it works when we do synthetic division. So I'm going to do one synthetic division to show you how to do the steps if you're not familiar, but you write the number you want to try to factor by and write all the coefficients of your polynomial here on the inside. So 10, negative 67, I'm picking these numbers here, 113, and then negative 20. And so what you do is you bring the first number straight down and rewrite it. Then you take this number on the outside times the 10 and write 10. And then you add those two numbers together and get negative 57. Then you take 1 times negative 57 and put that number here. Then you add these two numbers and you get 56. And then finally you take 1 times 56 and put it here. And negative 20 plus 56 is 36. And what you want here is that this number needs to be a 0. So since that final number is not 0, that means 1 is not a factor. So what you have to do next is come over here and do synthetic division by negative 1. And so I'm going to keep doing synthetic division here, and I'll pause the video, and I'm going to come back once I've found a number that is a factor of that polynomial. So I'm going to keep working here, and I'll pause the video and restart it when I found it. So I'm back. I was working for the last several minutes here trying to find it. And you see I tried 1, I tried negative 1. And notice I didn't go to the fractions. The fractions are just too hard. I wanted to try the whole numbers first. So I went to 2 and tried positive 2. Didn't work. Tried negative 2. Didn't work. And then I finally tried 4, and I finally got a 0, which means that 4 is a factor. So we know one of these factors is going to be 4, so it's either A or B at this point. Now we have to find the other factors, and now at this point, thankfully, what we know from synthetic division is that we have turned this into a quadratic. So every time you do synthetic division and it works, and you have a 0 left over, this x to the third function has now been turned into an x squared function because you have effectively divided it by x. So these numbers right here represent the coefficients on a new polynomial, and that new polynomial is 10x squared minus 27x plus 5. And now x squared functions, we know how to factor those. If they can be factored, we know things like quadratic formula, or we know completing the square, AC method. There's a lot of different ways to do this. And so I'm going to not bore you with those details. I'm going to assume you know how to factor this. I'm going to factor it right now, and I'll pause the video and come back when I've got it factored. But if you want help with factoring, I have other videos, and I'll make a link here at the top of this video right now to take you to a factoring video if you're not sure how to deal with this. But I'm assuming if you've made it this far in algebra, you're pretty good with factoring. So I factored it into 5x minus 1 and 2x minus 5. Again, if you want to check factoring really quickly, just multiply everything back out and see if it works. 5x times 2x is 10x squared. 5x times negative 5 is negative 25x. Negative 1 times 2x is negative 2x, so negative 25x, and negative 2x is negative 27x. And of course, negative 1 times negative 5 is positive 5. And so now we know how to deal with this. We can come over here and say 5x minus 1 equals 0. And 2x minus 5 equals 0, and set them both to 0 and find zeros the way we know how with quadratics. And with those two, I won't bore you with the algebra. X is 1/5 and x is 5/2. And so you see those zeros as well were on our list. We had those on our list right up here. So 1/5 and 5/2 were on our list as well. So for part B, you would select 4, 1/5, and 5/2. So that's the correct answer there. And then finally, the factored form would be these two parts we already had down here, the 5x minus 1, the 2x minus 5. And finally, this one that we factored here, recall that with synthetic division, when 4 works, that means that it was x minus 4 is the factors. That's one of the rules of factoring these polynomials when you do synthetic division. This number represents a factor of x minus 4, because what this means is if you plug in 4, you get 0. And likewise, right here, when you plug in 4, you get 0. So that would be the answer to part C. So I hope this helps, and let me know if you have any questions.